When you share a Chrome tab with Gemini, the model is not actually reading the raw HTML your server sent. What Chrome does is walk its internal render tree, which is the state of the page after CSS, layout, and JavaScript have already run, and then it builds a separate structured tree of typed content nodes out of that state. And whatever survives that extraction is the version of your page Gemini can act on. So that surviving set is what I am calling the render tree contract. Now, this whole picture comes from a teardown published by the SEO firm Dejan AI, because I have not found a Google technical spec naming this mechanism directly. Dejan's analysis documents a 21 typed node categories inside the tree. So everything from headings, paragraphs, and tables right down to dialogues, iframes, and disabled form controls. And every one of those nodes carries its own geometry, its own styling, and its own interaction state, which means a table actually gets classified as a table, not as a generic container the way a plain HTML parser would see it. The detail that turns this from a reading surface into an acting surface is really the node ID. Dejan's teardown describes every interactive element getting tagged with a stable reference, something like curly brace 14, and that ID is basically what lets Gemini click a button, fill in a form field, or follow a link instead of just summarizing the words on the page. Dejan's teardown counts 5 export formats for this same tree, and those node ID tags carry straight through into the markdown form, which is the one built for feeding an LLM's context window directly. My read is that this is the real difference from the earlier read the page for a model approach, because a summarizer only needs content, and an agent that actually acts needs a stable surface to act against. As far as privacy goes, 3 filters run during that same extraction according to Dejan's analysis. Password field values get redacted before the tree ever leaves the browser. Cross-origin iframe content, so an embedded payment widget or a syndicated reviews panel, collapses down to origin-only metadata instead of its actual rendered content. And paywalled sections get flagged through schema, which means the signal is structural, a recognized markup pattern rather than a visual overlay a person would notice on screen. Now, for the boundary itself, the render tree contract excludes anything Chrome's render tree never captures in the first place. So content that only loads after a click never enters that tree at all, no matter how visible it becomes to a person afterward. Content sitting inside a generic styled div instead of a real semantic element. So a table built out of nested divs instead of an actual table tag just loses the type that would let Gemini reason about it as tabular data. And a paywall with no schema org signal behind it gets no confirmed protection from this material at all. In terms of what to check against your own pages, there are 3 things. Does your primary content render in the initial server response, or does it wait for something to load after the page appears? You actually use real semantic elements, so an actual table, form, or dialog tag instead of a styled div standing in for one? And does your schema markup on anything paywalled stay accurate and concurrent? Those 3 moves are basically what satisfies the render tree contract, and it's the same advice practitioners already had, just with a second reason it matters now beyond search rank. The render tree contract is now a bar every page has to clear, separate from how it ranked in search. A page can rank cleanly and still fail this extraction, and a shared tab enforces that bar whether you build for it or not. The full teardown, the numbers, and my own firsthand caveat on what I have not tested myself are all in the Reddit linked below, and would genuinely like to know which page on your own website you think would fall or fail this extraction first. Thanks for watching, and I will catch you all in the next video.